How does it work? Why use two transistors in a monocircuit? Why use two LEDs and two LDRs in a monocircuit? Why should the LED be in the same position or pair as the LDR? Why use two 3.7-volt DC batteries in series? Can you use only one battery? So, before we answer all those questions, let's understand how it works first. The operation of the transmitter circuit is when the audio signal is input from the transmitter input pin. The audio signal will enter two electrolytic capacitors. These capacitors function to filter out DC voltage that can damage audio signal generating devices, and split the audio signal into two parts. After separation, the audio signal will penetrate the base pin of the TIP41 and TIP42 transistors. These transistors function to amplify the audio signal that was originally weak and unable to turn on the LED so that it can turn on the LED. After amplification, the stronger audio signal will reach the collector pin on both transistors, then both audio signals will pass through their respective 1 kilo ohm resistors, which function as voltage stabilizers for the LED supply. Because both LEDs have received the appropriate supply, both LEDs will light up and emit light that flashes according to the audio signal. It should be noted that each audio signal output from the transistor only supplies one LED, because there are two transistors, so the LEDs must also be two. The operation of the receiver circuit is when the LDR receives flickering light from the LED, there will be a change in resistance in both LDRs. Because only a change in resistance occurs in the LDR, we must supply voltage to one leg of the LDR. Because one leg of the LDR is supplied with voltage, the other leg of the LDR will output a variable voltage that flickers and changes for its voltage, and this voltage can already be called an analog audio signal. Because the output of the audio signal from this LDR is small, we need an amplifier, namely the two TIP41 and TIP42 transistors. After amplification, both audio signals will go to their respective 330 ohm resistors. After the two signals pass through the resistors, the audio signals will be combined again. The function of this resistor is for voltage stabilization. After that, the combined audio signal will pass through one electrolytic capacitor, which also functions to filter DC voltage. After passing through the capacitor, the audio signal can already be input into an amplifier such as an amplifier or another. Why use two transistors in one monocircuit? That's because audio has two polarities, namely positive and negative polarities. NPN transistor, TIP41 functions as an audio signal amplifier that is positively polarized. To work, the NPN transistor, specifically the TIP41 transistor, can only work if the base of the transistor is supplied with positive voltage. While on the PNP transistor, TIP42, the opposite applies. Why use two LEDs and two LDRs in a monocircuit? That's because one LED cannot transfer two audio polarities simultaneously. Meanwhile, one LDR also cannot receive two light inputs from LEDs simultaneously. Why should the LED be in the same position or pair as the LDR? That's because if the LED1, LDR1 pairing with LED2 and LDR2 are reversed, it can cause the audio output from the receiver circuit produced to be reversed for its polarity. Why use two 3.7-volt DC batteries in series? Because this circuit requires the splitting and rejoining of audio polarities, and requires two supplies with different polarities. Can you use only one battery? The answer is yes. How? The way is to use a DC to DC inverter that uses separate primary windings, or use a booster voltage whose primary and secondary windings are separate, and there are two output polarities, namely positive 3.7 volts, 0 volts, and negative 3.7 volts, or can be called a CT voltage. That's all for the explanation. If there's anything wrong, please correct it. Please remember that this is just a schematic, so there's a possibility that the result may not be accurate. For those of you who want to try it, please be careful and experiment first, and if there's any problems such as burnt components, it's your own responsibility. In this schema of mine, I'm confident that there won't be any components burning, unless you make a mistake in the connections.